Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on the 24th of June, 2025, T 17 hours, 59 minutes, and 55 seconds, .0000Z. This paper, published just 2 days ago, introduces a new captioning strategy that boosts performance on the MMVet benchmark by 7%. The paper is titled ScaleCap, Inference-Time Scalable Image Captioning via Dual-Modality Debiasing, and it does this by tackling some really common problems with today's vision models. The authors propose a clever two-part system to create richer image descriptions, while also filtering out the tendency for models to, make things up. Also, the authors shared their official repository, and it's packed with everything you need. You'll find the full training code, evaluation scripts, and a quick start example to try it out yourself. They also provide access to that massive 450K image caption dataset they built for the project. Alright, so to really see what this means in practice, the authors provide a great visual. It shows an image of a home office captioned by 3 different systems, their new ScaleCap, and 2 other advanced models, Qwen2, VL72B, and GPT-4o. These are powerful AI systems known as large vision language models, which are designed to understand both images and text, and you can immediately see the difference. The ScaleCap caption is incredibly rich, describing the woven chairs, the art, and even the specific printer which the others miss. So, how does ScaleCap actually achieve that rich, detailed description? Well, this diagram breaks it all down into a clever 2-stage process. First, there's a module called Heuristic Question Answering. This part takes an initial simple caption and uses an LLM to generate specific follow-up questions about objects and their positions. Then, to fight hallucinations, a second module called Contrastive Sentence Rating kicks in. This rating system cleverly checks if a sentence is truly based on the image, or if the model is just guessing. The good, visually grounded sentences are kept, and everything is then combined into that final high-quality caption. So, all that clever engineering with question answering and sentence rating, does it actually work? Well, this table lays out the proof. It compares several models after they've been pre-trained on different caption datasets, including the new ScaleCap 450K dataset. And the results are really clear. Across 11 different benchmarks, from InfoVQA to MMVet, the models trained with the ScaleCap data consistently get the highest scores. Looking at the .2.57b model, its average score jumps to 64.7, a really solid improvement that shows the quality of these new captions. Building on those impressive benchmark scores, these charts dig into how ScaleCap is so, scalable. The line graphs on the left show that as you feed the system more instructions, those specific follow-up questions, the accuracy on the MMVet and MMStar benchmarks climbed steadily. More questions mean a better understanding. Then, the bar chart on the right shows something really interesting. For simple recognition tasks, just identifying objects, a 7 billion parameter model does just as well as a massive 72 billion parameter one. But for tasks requiring world knowledge, bigger is still better. Okay, so these next tables really put the components to the test in what's called an ablation study, where you take parts away to see what matters most. The table on the left confirms that a 7 billion parameter vision model is good enough for seeing the details. But you really need that big 72 billion parameter language model to put all the information together well. Then, the table on the right shows how well the system fights hallucinations, using a metric called Caption Hallucination Assessment with Image and Reference, or CHAIR. And the results are stark. The golden sentence method slashes those hallucination scores, proving it really works. So, to wrap things up, the key takeaway here is that ScaleCap offers a really smart, scalable way to get incredibly rich and accurate image captions. By using that 2-step process, asking targeted questions and then filtering out any made-up sentences, it effectively tackles the model's biases. And the big payoff is clear. Training models on these superior captions leads to major performance jumps across a whole range of tasks. It's a powerful framework for creating more comprehensive and factual vision language systems. That's all for today's AI Research Roundup. Thanks for tuning in.